The first lab lets you explore the electrostatic potential at different distances from a single point charge. The charge will be placed near one edge of the display, say the left, and a voltmeter and slide rule will be used to measure the voltage at different distances from that charge. The data will then be graphed either by hand or using Excel or some other graphing software. If the initial graph of the data is not linear, it will be necessary to linearize the data set and replot. From the slope of the linearized graph, one should be able to extract the numerical value of Coulomb's constant and compare that value to the accepted value by finding the percentage error between the two. All graphs completed from the data should be included in your Word document lab write-up after the questions section. Each graph should be on its own page and stretched to fill that page. See the specific instructions outlined in the syllabus and on Blackboard for proper graph insertion in lab write-ups. In the second part of this lab, you're going to use a pair of charges, a positive charge and a negative charge, and you're going to map out the electric field created by this pair of charges. But the way you're going to map out the field is by measuring the potential differences at different distances located between the two charges. You will use a voltmeter and measure the voltages at certain distances. You may find the mapping easier if you put the charges on exact intersections on the grid and on the same line, with quite a bit of space between the two. You can then use your voltmeter to find potential difference values between the two. You should find more than a few of these equipotential lines, so move out from one of the charges toward the other one block at a time. When you click on that block with the voltmeter, you will be shown a ring with the same potential difference. The more of these you get, the more accurate the electric field will be when you create it. Once you get the potential field completed, use your computer's zoom option to make the field as large as possible if necessary. This will make mapping a bit easier. Make sure not to make it so big that you remove any part of the field or the charges producing it. Once you have the field as big as possible, you can use the print screen option on your computer to print this field. You just go to print and send it directly to your printer. Or you can use the snip tool in Windows to capture the entire field. Again, make sure to include both the charges producing the field. You can then print this picture using your printer. On the printed map, go to each of the potential difference lines and make a little tick mark that is perpendicular to the curvature of the arc at that point. Put these at similar distances along each arc. You'll want to do 5 or 6 places along each arc. Then you connect them by doing a freehand sketch, connecting those tick marks, producing a curved line from one charge to the other. This should produce about 5 to 6 arcs in total to represent the electric field. In your textbook, section 17.3, it shows you equipotential surfaces, which are what we have here, and how we can use them to visualize the electric field for the same charge configuration. This will give you an example of what your diagram should look like. The completed sketch of the electric field becomes the graph for this part of the lab that you will attach to your lab write-up. You will open a new blank page after your previous 2 graphs and insert it in that blank page. One caution about pictures. Cameras on phones and digital cameras in general have the resolution set pretty high to get clear images. This means that the picture comes out in megabyte range. Blackboard has a limit to the size of files it will accept. So if you can go into your camera and reduce the resolution so that maybe you're producing a picture that's in the 100K range, so 1/10 the resolution of a 1 megabyte image, you should avoid this issue. A single picture may not make the file too big to be uploaded, but if there is an issue, reduce the resolution of the image and import that image into your Word document. What you will submit. In addition to the filled lab table and the answered questions, your lab write-up should include the graphs that are asked for in the write-up and the completed calculations on a separate calculation sheet following the graphs.